Hi, this is Bill Malik, and I'm here with your bit of security for Friday, the 16th of February, 2024. We're going to take a deep dive into the software development lifecycle. There are a few things there that I think we need to consider. Now, there are many varying methodologies used for software development, but they all come down to this basic principle. There's the defect injection phase, and then there's the defect detection phase. And what I'd like to talk about is the defect injection phase. That is the process by which we create software. I said in an earlier talk that so many of the code defects we had that lead to security problems come about because of just poor coding practices. The use of memory-safe languages cuts the instance of problems in uh, Google Chrome, for instance, by 70%. So being able to design programs that avoid known pitfalls is crucial. But there's a deeper lesson here. If you look back at the history of public health, the biggest advance that was made in terms of keeping us all alive and well and healthy was the use of clean water. The ability to have clean water to get things done, to cook, to drink, just made life so much safer and so much better for so many people. All sorts of diseases were avoided through that practice. In medicine, the discovery of germs and the notion that one should wash one's hands before performing a surgical procedure, that came about in the late 19th century, and there was a significant amount of resistance to it. But we now know that if you clean your hands, you have a much better outcome from any kind of surgery. So what I'd like to do is suggest that we need to look at the creation of code and see how, in fact, we can do it better. Now, the capability maturity model did a lot of work on figuring out why organizations create clean code more often than other organizations. And the difference doesn't come down to which language they're using or which school they went to, but how they solve problems. I'll have more to say about that, but here's a teaser. In 1987, Professor Harlan Mills came out with a paper called Cleanroom Software, where he talked about a way to approach the creation of code that led to an extremely small number of defects in the final product. Part of it was because of the way you design the code, you don't spend time doing unit test. You don't need to. The language will tell you if there are problems with the syntax, and the design process will tell you if there are problems with the semantics. And by cutting down on the negligent activities in the defect injection phase, we can substantially improve our outcomes and reduce the headache and heartache during the defect detection phase. Happy coding. That's your bit of security, and I'm William Malik.